Welcome back to day 8. Today's project is Fibonacci sequence generator. The goal here is to build a command line interface CLI tool in Rust to generate the Fibonacci sequence up to a user defined number of terms. This project will improve your skills in user input handling. Accepting and validating user input is what we are going to do. In control flow, where you will be using loops for, while, for sequence generation. We'll be doing some arithmetic operations where we will be calculating the Fibonacci series. And we'll be looking at some error handling where you'll be managing invalid or edge case inputs. And finally, we'll be looking at some functions where we will be organizing our code into reusable functions. So first, let's see what is a Fibonacci sequence. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, starting from 0 and 1. The mathematical representation is f of n equal to f of n minus 1 plus f of n minus 2. So if you have to look up the first 10 Fibonacci numbers, it will show something like this. It starts with 0 and 1, then the addition of 0 and 1 is 1, 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, and so on. So to build this, let's go ahead and set up our project. So I'll go ahead, and I've already created day 8 folder which has nothing inside it. So I'm going to say cargo new Fibonacci underscore generator. There you go. It creates one. I'm going to say cd into that, clear, and I have it open here. I'm going to open this inside my Sublime text, open my main.rs, remove everything, and start from scratch. So first step is to get our library. So I'm going to say use std.io because I'm going to take user input in this particular case. Next thing, let's start with our main function. Inside our main function, let's add the welcome message. So I'm going to say println Fibonacci sequence generator. Next thing, I want input from user. So I'm going to say println, enter the number of terms you want to generate. In this case, it's like how many number of Fibonacci or how long do you want this number to be. So next, once I'm done with that, I'm going to go ahead and create a variable number of terms equal to match get input as u32. So I am writing a function here which is get input as u32, which I'll be writing in a little while, which will return back to me a number which might be a number or might be nothing. So if it's nothing, which means I'm going to say invalid input, please enter a positive number. If it's something, if it's a number, then it's good, or else I need a number. And I'm going to close the function and get out of the program if it's none. So that's the first step. So I'm trying to read the user's input. Now, next step is let's check if number of terms equal to 0. So what if user says 0? In that case, I'm going to say number of terms must be greater than 0. It can't be 0. And I'm going to return empty and close the program. Again, next one is I'm going to create a variable sequence and call a function generate Fibonacci and pass it the number of terms variable that the user has entered. Once I have that, I'm going to say Fibonacci sequence for these many terms equal to whatever is generated back from that function that I've created. So pretty straightforward. Now this looks like a pretty straightforward code, but again, the main meat is still there, which is getting the input from the user and generating the Fibonacci series. So what I'm going to do is I'm going to scroll it down. First, I'm going to read user's input and attempt to parse it as u32. So I'm going to say create that function that I have written above, get input as u32. So this gets called here, and it's going to give me either a u32 or nothing. So either it's going to give me a number or nothing. So I'll say I'm going to create a mutable input variable, and that I am initializing as a new string. And then I'm going to use my IOSTD input to read the line and pass it the input. And if it doesn't work, I'm going to say failed to read input. Next, I'm going to try to match the input that I get from user, trim it, parse it, and if it's u32, I'm going to say all good. I'm going to return that, or else if there's an error, I'm going to say none, and that's what is returned back, and that's what comes back to this number of terms. Now once that is done, that takes care of this function. Now next function is generating a Fibonacci sequence up to n terms. So I say function generate Fibonacci series, and I'm going to use that n as a variable, and it will be of the type U32 as a parameter, sorry, not a variable, and that's what is passed by what user wants. And then that will return back a vector of U64, which will be returned back to this, which will be displayed to us in the terminal. So let's go here and create a mutable sequence variable, which is of the type vector. I'm going to say n is, if n is greater than or equal to 1, sequence.push 0, which is the first term. If it's greater than or equal to 2, then I need to push the 1. So 0 and 1 are the first two numbers. If you remember 0 and 1, so I'm manually pushing those in. Next, for I in 2.n, from 2 to n, which is the number of terms that user has requested, I'm going to say let next equal to sequence of I as u size minus 1 plus sequence I as u size minus 2. So I'm taking the previous two elements and then adding them up. That will give me the next item, which I'll push it back into the sequence. So it's going to keep on looping in until the value of n is reached, and then I will return back the sequence that is generated from this for loop. There you go. So it will start with 0, 1, and then it will keep on adding the summation of it into the vector and pass it back to whoever called it. Again, first we give a welcome message to the user. We ask them to enter how many terms that you want, and depending on the terms, if it's a valid number, we're going to say valid number or not equal to 0, we're going to say generate the Fibonacci series here, and we call that function get push the first element, second element, and until the end terms, you're going to keep on adding and pushing that into the sequence and return it back to whoever called it here, and then print it out to the user. So I'm going to save this and then go back to my terminal and say cargo run. Compile, build, and it says how many numbers you want. I want 10. So here, there you go, 0, 1, 1, 1, 2, 8, all these numbers are displayed here. Again, run it again. This time I'm going to say 8. And there you go, we have 8. Again, I can run it again. And then this time I'll say 2. It just says 0 and 1. So there you go. So we were able to generate Fibonacci series sequence here, depending on how many terms we requested. So I hope you were able to follow along and learn about input validation, where we used parse and match in this particular case here. And we were able to write the Fibonacci logic, where we calculated Fibonacci numbers using a loop right here. And then we also stored numbers in a vector, which is dynamic data storage right here. And we did some error handling, manage invalid and edge case inputs gracefully, all the places where X is there here. And we created kind of a modular code where we had modular functions, separated input parsing and the Fibonacci generation logic on separate functions. So I hope you were able to follow along. Now, if you want to do something more to this, you can do a recursive implementation where you can implement the Fibonacci sequence using recursion. Another option is you can limit by the maximum value, allow users to set a maximum numeric value instead of the term count. And you can add color output, display odd numbers in one color and even numbers in another. So try it out, have some fun, and let me know if you have any issues or problems or have any questions in the messages, and I'll get back to you.